Here we're given a scenario where we have a single sample and we want to extract information from this sample. The question says, in a sample of 10 students from a math class, the average math test score was 55.4 with standard deviation 7.2. Is there evidence to suggest that the average math test score for this class is greater than 50? So the null hypothesis here would be that the true mean test score is equal to 50 and the alternative that the true mean test score is greater than 50. Note it's a one-sided test here because we're interested in seeing whether the true mean test score is greater than 50 as opposed to not equal to 50. Next, we extract the sample variables from the question. We're told the sample is of size 10, so n is equal to 10. The sample mean is 55.4, so x bar is equal to 55.4, and the standard deviation is 7.2, so s is equal to 7.2. In this scenario, we're not told what the population standard deviation is, so we must use a t-test as opposed to a z-test. Furthermore, the sample size is small at n equal to 10, so the central limit theorem does not apply. It only applies for large n, usually that means n greater than 30. So again, we cannot use a z-test, we must use a t-test. The sample statistic for the t-test is the sample mean minus the hypothesized null value of the mean divided by a sample standard deviation on root n. Substituting values into this formula gives 55.4 minus 50 divided by 7.2 over root 10. Evaluating that on your calculator gives 2.37. Now, to find the critical t-value to compare the test statistic with, we look at the student t-distribution tables. The degrees of freedom is n minus 1, which is 10 minus 1, which is 9. So along the rows, we look at the row corresponding to 9 degrees of freedom. And as per convention, we use an alpha level of 5% or 0.05 in decimals. So along the columns, we look at the column with 0.05. Now we look at where the row and column intersect to obtain the critical value. In this case, the critical value is 1.833, and we see that our test statistic is greater than 1.833. Therefore, we reject the null hypothesis because the test statistic is greater than the critical value. So we reject the null hypothesis and conclude that the true mean test score is indeed greater than 50.